If you look at a map of India, you'll immediately spot a massive inverted triangle dominating the southern peninsula. This is the Deccan Plateau, a vast highland flanked by two mountain ranges, the Western and Eastern Ghats. On the surface, this immense region is a thriving agricultural powerhouse. It produces a massive portion of the nation's cash crops, most notably vast, dense yields of cotton. Moving from the fields to the factory floor, the plateau hosts a heavy industrial sector, producing high volumes of advanced SUVs and passenger vehicles. Those assembly lines are fed by foundational industries operating in the same region. Towering blast furnaces produce the heavy steel and cement required to maintain this level of manufacturing. This modern economic output is the direct result of a geological lottery hiding right beneath the topsoil. Contrast this with northern India. The north is defined by the Himalayas, young, jagged fold mountains thrust into the sky by recent tectonic collisions. Below those peaks sits the Indo-Gangetic Plain. It's a flat basin filled with thousands of feet of soft, loose river sediment, providing the deep alluvial soils that grow the nation's wheat and rice. Southern India is built differently. It is rocky and rigid, functioning as a vault for heavy industrial wealth rather than just a breadbasket. To understand that rigidity, we have to treat the plateau as a stacked time capsule, excavating downward through its structural history. Northern geography excels at growing food and maintaining borders. The ancient rock of the south functions as the raw industrial engine for the entire subcontinent. Digging through the modern topsoil leads to the first major historical layer, the end of the Cretaceous period, roughly 66 million years ago. During this era, a series of volcanic fissures ripped open. Endless rivers of fluid lava flooded the entire region. As the eruptions stopped, that lava cooled into a dense igneous rock called basalt. Successive eruptions created massive stacked layers, forming steep stair-like mountain ridges. This is the Deccan Trap, a terraced basaltic shield sitting on older crust. Over millions of years, tectonic shifts and heavy monsoon rains broke this hard basalt apart, grinding it down to form the region's famous black soil, which holds moisture during long dry spells. The massive cotton fields feeding the surface economy today rely on the nutrient-rich ash of that ancient volcanic destruction. Now we bypass the basalt and dive much deeper into the Earth's crust. Millions of years further back in time, we hit the Archean-era bedrock. Formed over 2.5 billion years ago, this is one of the oldest stable landmasses on the planet, a remnant of the ancient supercontinent Gondwana. Down here, unimaginably heavy tectonic pressures and blistering subterranean heat crushed the original crust, baking it into dense metamorphic rocks like granite, gneiss, and quartzite. This tectonic cooking process consolidated high-value raw materials. It forged enormous deposits of bauxite and iron ore right into the bedrock. Meanwhile, along the eastern edges of this plateau, dead organic matter was trapped and compressed within deep sedimentary basins, eventually solidifying into vast coal reserves. The Gondwana Shield acts as a geologic vault, hoarding the raw elements required to sustain a modern industrial civilization. Bring those layers rapidly back to the surface. Look at this split perspective. The sprawling steel mills operating above ground exist here because the massive iron and coal deposits are sitting right below them. The bauxite, used to make aluminum, and the nearby limestone deposits feed directly into the region's automotive and cement industries. When you look at a modern city in southern India, you are looking at the ancient Gondwana landmass. Every car, factory, and concrete pillar is simply deep rock that has been dug up and completely reorganized. The Deccan Plateau shows that a region's industrial capacity is shaped by the deep, violent geologic history buried beneath its feet.